Where they now tell you conversion of from kilometer per hour to meter per second. Now instead convert 100 kilometer per hour to meter per seconds. They ask you to convert. Now it's very simple, but you need to understand that in case they tell you to convert kilometer per hour to meter per seconds, you just come here and say 100 times 1000 over 3600. So anytime you are multiplying, you are converting from kilometer per hour to meter per second, you always multiply by 1000, then divide by 3000, what? 600. That is what you do. You understand? So maybe they tell you convert 360 kilometer per hour to meter per seconds. Now you just come here and say 360 times 1000 over 3600, 0000, 36 here 1, then this is giving us 10. So 360 is going to give us 100 meter per seconds. Yes, 100 meter per seconds. You understand? So just have to know that whenever you're converting from kilometer per hour to meter per second, you must multiply by 1000, then divide by 3600. The reason why you multiply by 1000 is that 1000 meters make 1 kilometer. Then the reason why you multiply by 3600 because 60 seconds make 1 hour. So you divide by 3600. 60 seconds make 1 minute, I mean to say. So 60 minutes make 1 hour. So that means 3600 seconds will make 1 hour. So you need to multiply by 1000 and divide by 3600. Now, let's try out this question. In this question, like I said, anytime you're solving physics question, you have to be able to interpret it by writing out all the necessary parameters. Now, in this question, I'm telling you that a body moving with a velocity they tell you a body moving with a velocity of, that velocity is called the initial velocity. So the velocity is initial velocity, which is u. They didn't tell you the body starts from rest, so it means that the initial velocity is not zero. So moving with a velocity of 144 km per hour, so we have 144 km per hour. Now we need to convert this to meter per second, so we multiply by 1000, divide by 3600, then uniformly decelerated to 36 km per hour. So we're having v to be 36 km per hour. So we multiply by 1000 and divide by 3600. Okay, in 6 seconds. So t equals to 6 seconds. So we're not converting seconds, converting time. And I said find the distance traveled in this time. So let's convert 0, 0, 0, 0, 36 here 1, 36 here 1. So we're having 10 meter per seconds. 0, 0, 0, 0, 9 here 1. 9 into 36 is 4. I think 9 can go here. 9 into 14 is 1. Remainder 5. 9 to 54, I think that is 6. 9 to 54, 9 to 54 should be 6. So 6. Okay. 4 here 1, 4 here 4. So we're having 40 meter per second. So now you check this. We have u, we have v, we have t, and they say we should find s. Now let's go back to our formulas. We have v equal to u plus at. We have s equal to ut plus half at squared. We have s equal to u plus v over 2 times t. Then we have v squared equal to u squared plus 2as. Now check this formula. U is here, u is here, so we can use this. V is here, v is here, t is here, t is here, but we don't have a, so we can't use this. S is here, u is here, but v is not here. So s, t, u, and v, so we can use this. So now we can say s equal to u plus v over 2 times t. So what was u here? U is 40. What was v? 10. Was divided by 2 times t, which is 6. So this is giving us 50 over 2 times 6. And this is giving us 2 here 1, 2 here 25. So 25 times 6 will give us 150 meters. So we're having s to be 150 meters. So you get the point now that whenever you are given a question, you need to interpret the question. Then when you're able to interpret the question, then you can apply the question to solving the question. So whenever you're given a question, you should use the question to interpret the question so that you can use that question to answer the question. Take note of this. Now, let's check this one out now. It says, how long does it take a body to fall to the ground from a plane flying at a height of 8 kilometers? Now, they will give us height to be 8 kilometers. Now, remember, I said t equal to square root of 2h over g. Now, they told us 8 kilometers. You can't use 8 kilometers. Rather, you convert it to meters. That's 8 times 1,000, which is 8,000 meters. So we have 2 times 8,000 over 2 over 10, because g is 10. This is giving us 16,000 over 10. And this is giving us 1,600. Square root of 1,600 is going to give us 40. 40, yes. So we're having t to be equal to 40 seconds. So we take note of that. Now, this now takes us to another area of velocity, which is called the velocity time graph. So we'll go to velocity time graph right away. Now, on that velocity time graph, I would love you to be very careful. I would love you to be very careful, number one. I would love you to be very observant. Now, firstly, I'm going to give you some instances. Velocity time graphs now. Velocity time graphs. I'm going to give you some instances, and I would love you to be very careful. Now, that velocity time graphs, this is how it works. Let's say we have this now. This is going to be v. You know, unit of v is meter per seconds. Then this is going to be t, seconds. Now, this is 0. You know, at this place, the origin is always 0. So, the body starts from rest. That means the initial velocity is 0. This is initial velocity. So, start from 0. Then the body now, they now tell you the time, which we don't know. So, we can say, yes, t1. The body now had a constant acceleration. Let's say the body starts from rest. Let's put it like this. The body starts, accelerates uniformly from rest, I mean to say. So the body, this place is a uniform acceleration, I mean to say. Then this place now had a uniform velocity. So this place is uniform acceleration. This place is uniform velocity. Then now the body now had a uniform retardation. Uniform retardation. Retardation has to do with deceleration, the body going back to rest, like you applied brakes. So I'll go again. Uniform acceleration, it accelerated uniformly from rest, had a uniform velocity, then had a uniform retardation. So that's point 1. We can have this. We can also have point 2, another form now, which is the body accelerates uniformly from rest. There was now an increase. Okay, there was now a decrease in the acceleration. Now you observe decrease in acceleration. Then the body now had a constant velocity. Then the body now had a uniform retardation. So this one is T2 and this is T3. So this is T1, this is T2, this is T3, and this is T4. And this is our time in seconds. So we can have something like this too. This is our V, meter per seconds. Now, this is our U and this is our V. Now, this is S1, S2, S3. S1, S2, S3, and S4. Now, if you observe this very well, this is what we have. Now, first thing you will observe now in this aspect is we have a triangle here, we have a rectangle here, then we have a triangle here. Now, in this case, we have a triangle here, we have a trapezium here, we have a rectangle here, and we have a triangle here. Now, this full shape you are seeing here is a trapezium. We can actually solve it as a trapezium, or we can find the triangle, area of the triangle, the area of the rectangle, and the area of the triangle, the area of the triangle, area of the trapezium, area of the rectangle, and the area of the triangle. You take note of this. Now, this now takes me to the first question, first aspect which I drew there now. So I'm going to talk about the first aspect, in which we have something like this now. Now we are having something like this. This time, and this is our V, meter per seconds. Now body starts from rest, so we're having this. Now we're having this, and we're having this. Now what we are going to do now, this is our S1, this is our S2, this is our S3. Now for us to solve this, the first thing is we're going to find S1. S1 is area of triangle, right? So area of triangle, area of triangle. Remember that area of triangle is equal to 1 over 2 base times height. So we'll find the area of triangle. Then S2, which is our area of rectangle. Area of rectangle, which is equal to length times breadth. Then S3, which is our area of triangle. Area of triangle, which is half base times height. Then what we'll do at the end of the day is to say S1 plus S2 plus S3. And you know what I call this? I call this TDC, total distance covered. Total distance covered, TDC. Now, after getting our TDC, this is T1, this is T2, and this is T3. We will now say, okay, the average speed, which we will now look for AV speed, is equal to the total distance covered over total time taken. So whatsoever the time it takes to complete this full velocity time graph, to complete this full setup, we are going to work with it to get our average speed. You understand? So let's try out a question in this regard.